Okay, here's our example from class where we're simply given variables and asked to find the force and the support and the support. So there are a couple things that we know, and that is that this mass has some length. We don't know what it is. If you want to in your brain, you could call it L. You could call it 1 meter. That might be easier. But the reality is that the force is going to be sort of distributed by some amount to both of these, no matter what scale we're looking at. So we could be looking at a whole mile or 1 meter or a foot, and the force will be distributed in the same proportion between these two, regardless of the length. So center of mass is going to be in the middle, and in the middle, and in the middle. And if we look at these distances, we know that this is half of the length, or the 1 meter, or whatever you're going to call it. This would be 3/4, and this would be 7/8. So I think what most people were doing in class was actually solving from the other side. So using this example, I will be calling this the point of rotation. Sorry, this right here, the point of rotation, where this is the radius, this is the radius, or this is the radius. So we're going to add the torques together. The torque due to this mass, the torque due to this mass, and the torque due to this mass are canceled out by the torque due to this support. So we're basically adding up torques. Torque, I'm going to use lowercase t because that's more common. So torque plus torque plus torque equals torque, where again these three are for these three masses, and this is for the force. So I'm going to say that, well, first of all, when we're calculating torque, it is force times radius. And so force is going to be the weight of this, and the weight of this, and the weight of this. And radius is going to be 1/2 and 3/4 and 7/8 of L, or a meter, or a mile, or whatever it is. So we have mg times 1/2 plus mg times, that's a 3/4, plus mg times 7/8. If you can hear that music in the background, I apologize. Should have turned off the Pandora. And here, the torque due to this support is going to be our force. This is what we're solving for. This is force in support 1 times the length, which is 1L, or meter, or whatever we're calling it. Okay, so we're going to add 1/2 plus 3/4 plus 7/8. Little fraction review for you. 1/2 plus 3/4 plus 7/8 is 17/8. Okay, looks like some answers we saw in class today are good. mg equals F. So voila, the force in this support